As you said, I'm Kshitij Sobti from OpenCraft, and in today's talk, we're going to explore how a pretty simple client requirement, which was to have multiple sites on a single instance, each having a separate theme, really exposed a lot of the weaknesses and fault points in the way that we deploy instances and in the way that we theme instances. So we're going to dive into some of the future technologies of MFE theming. I say future, but a lot of these technologies are already there in MFEs right now. You can take advantage of them. There are one or two things that still need to be not merged exactly, but I think with the next release, things are going to be very, very different. So before we get into the future of MFE theming, or as it is now, present, the reason I'm jumping forward and backward in time is because in the period of time when I wrote this talk and now, a lot of these things have already become a reality. So I've been working with edX for about 7 years, and in the number of, in release terms, that's 13 releases ago. I started with Ginkgo, and with Ginkgo, the best way to customize the theme of an instance was comprehensive theming. And the way that that worked was that you would have, you could override individual templates, SCSS files, and wherever the platform found something from the theme that had been overridden, it would use that instead of the base version. And the problem with that mechanism of theming was that in the OpenEdX platform, a lot of the theming code is, a lot of the layout code is mixed in with Python, and that means that every time you're creating a comprehensive theme, you're essentially creating a fork of that part of the platform. And every time you have a new release that comes out, you need to consolidate all the changes that you have made to your comprehensive theme with the changes that have been made upstream, bring those together, and hope that everything works. If you don't do that, if there's any mistake, because there's logic involved in the templates themselves, you could end up in a situation where there are differences in what data the templates expect. The worst case is a broken site. The best case is a broken site. The worst case is there's some data corruption or worse. So this was pretty high maintenance, and we really wanted to come up with a better solution. So we had an internal tool called OSIM that we used to use for deploying instances. And with each deployment, it would rebuild the entire instance from scratch, deploy it, and then you could switch to the newly deployed system. This deployment mechanism wasn't perfect. There could be an issue on the NPM side. Maybe the URL doesn't resolve, a package doesn't resolve. There could be an issue with PyPI. There could be an issue with the hosting provider, and the first deployment doesn't work. So what could be a 2-hour deployment time could turn into a 4-hour, 6-hour, or even 10-hour deployment time if things went wrong. And eventually, when we moved to a system where we gave our clients control of deployments, where we allowed them to make changes to the theme, we allowed them to make changes to add static pages, add other customizations to their site, all through a client-facing UI. This was now exposed to our clients as well. They could click a deploy button, and the slight theme variable change that they made could show up on their site in 1 or 2 hours, or it could take multiple rounds of deployments if the first one didn't fail. So it's obviously not the best experience, and we started looking into ways to improve that. And with MFEs on the horizon, one thing that we really wanted to do was see if we can have a new system for theming that would be more flexible, allow altering, make deeper changes, allow making more changes, have somewhat stable API so you could go from one release to the next without things breaking. Unfortunately, we had some changes in OpenCraft itself where there was a change in our direction, the change in the kinds of clients we were seeing, that combined with the fact that we are now moving from the edX configuration repository for deploying to Tutor and Kubernetes. there were just too many changes, and eventually we kind of dropped our old OSIN project entirely. So that's not what we use now. We use a different thing called Grove. But the client requirements didn't change. Our requirements didn't change. We still would like better theming, more comprehensive theming. While we were still working on investing a lot of time and effort into this project, we created a couple of discoveries which were regarding how we can change the theming system to make themes work faster, build faster. We published some of those results, but that's kind of where our project ended. So in that early phase of the project, we looked into something which is close to what runtime theming is now, which was essentially an MFE. This is like just an example MFE where you could click a button and it would load a completely different theme at runtime on the same site. But this did not really align as much with our interests anymore, because what we wanted were faster theme deployments. We wanted ideally more stable theme deployments, but runtime theming, not as much. But then we came across a client requirement that really made us reevaluate. So before we look at a runtime theming, let's have a quick look at how theming works in MFEs. So very early MFEs did not support theming, but this was like a very, very early phase. There was an OEP called OEP 48, which introduced brand customization and branding packages. So if you're familiar with the way the header and footer components are customized in MFEs, the way that branding packages work is pretty similar. Essentially, you can drop in a replacement package, and it will pull just like you would replace the header with a custom header or a footer with a custom footer. You can replace the branding package, which the default branding package is just empty SCSS files. You could replace that with your own customized theme, customized SCSS, and it would build your MFE with that. So MFEs are built on Paragon, which itself is built on Bootstrap, which itself is built on SCSS. I'm going to use SCSS and SASS interchangeably here. They're not the same thing, but it's just in my memory now, so I'm going to just roll with that. So SCSS is essentially like a programming language on its own, which is used to generate style sheets. And here's an example. Like, there's a small snippet of code. You can see that you have functions, you can have loops, you can have conditional statements. You can have almost everything that a programming language does, except the output is a CSS file. So, for example, you could have just a few base colors defined in your branding package, such as the brand color, the primary color, the warning color, all these things. You can customize those, and from it, the SCSS code will derive lighter and darker variants of that. So just changing a few variables can have a huge impact on the final visuals of your site, because even lighter and darker variations will be impacted. Now, how does this interplay with multiple sites? Well, what are the challenges that come up? So as I mentioned, each MFE has the branding package installed, it has the header installed, it has the footer installed. So every time you are building an MFE, you are building that those entire set of packages. And this is repeated for every MFE, which means that if you make a slight change in your branding package, if you make a slight change in the theme, all the MFEs need to be rebuilt and need to be redeployed. And that is a pretty large amount of effort and time that goes into work that's somewhat repetitive, because the base Paragon package does not change. And the way that this worked in the comprehensive theming days was pretty simple. You could install multiple comprehensive themes onto one instance, and in the Django admin, you can associate a theme with a particular site, and it would load the correct site. But how do you do this with MFEs? So there was no ready-made solution, honestly, and we had to explore and kind of struggle with creating something of our own. So since each MFE comes built in with its own theme, if you want an MFE with multiple themes, you just need to build multiple MFEs. You need to build the same MFE with a different theme for every theme variant that you want to have. So for our client, we needed to have dozens and dozens of sites, each with a different theme. And what this essentially meant is that each MFE, there were 9 at that point of time when we were working on the project. I think there are more now. Each of those MFEs needed to be built multiple times, once for each theme, once for each site. So the first issue we faced was that there were some settings that you just can't configure from site configuration, which we need to vary on a site-by-site basis. But this was pretty easily solved. There's an amazing package by edX called EOX tenant. It introduces a concept of tenants where each tenant is similar to an earlier site, and it allows you to make certain changes to Django variables, which you cannot with the traditional site configuration mechanism. So this problem was solved. So then we come to our next issue. Tutor and the MFE plugin for Tutor don't come out of the box with any kind of support for multiple sites or themed sites. Creating multiple sites or theme sites is, even without theming, is important, because if you have multiple sites but there's only one base domain for your MFEs, that means users from all of those sites will be redirected to the same base domain for the MFE. And what that means is that since the configuration is loaded on a per site basis, that means you cannot vary that configuration for each MFE. For example, you might have different sites with slightly different logos, slightly different headers. You can't do that easily. So our solution for this was to create a kind of fork. This was supposed to be temporary, of the MFE plugin for Tutor. And essentially what that did was, you give it a list of all the sites that you want deployed. You give it a list of themes for each of those sites. You set up all that configuration, and it's going to build a different variant of every MFE for every site, set up the correct URLs, and it works. Right? At this point of time, essentially our problems are solved. But then when you make your third site, you start running into problems, which is not ideal. By the time we had a third site configured, we were running out of disk space on our build machines. This is a pretty easy problem to solve, just increase the disk space, right? Then we came up with this second issue. It takes too long. We're running into timeouts. Again, it's a pretty easy problem to solve, just increase the timeouts. And this turned out to be a little more complicated than we would have hoped, because GitLab has like multiple layers of timeouts. There are timeouts on the layer of the CI machine. There are timeouts at the layer of the I don't want to get into it, but even something as simple as this really made me scratch my head. Then another issue that I didn't even know existed, there's a limit to how many layers you can have in Docker files. And the reason for this was essentially that we were basically multiplying the number of layers by the number of sites. So each site was creating essentially its own set of layers. And this was a pretty easy thing to solve. We refactored the Docker file, and we ended up in a situation where it creates only one layer per MFE with all the sites bundled into each layer. This was an easy problem to solve, but the next problem is much harder. So the timeouts don't only exist in machines. Like, humans have our own timeouts. It's irritating when you have to wait too long. We were at 3 or 4 sites. It was taking hours already, and we knew if we were heading toward a future where we needed, in our case, 50 sites, it was going to take over a day. This is just not feasible, right? I mean, we still had all the old issues. You could have timeouts on NPM at the 21st hour, and you have to start from scratch. It's hard to explain to a client why a small theme change still hasn't shown up 2 days later because an NPM package failed to resolve. So we looked at a few solutions. We can have better build machines. We can improve the way that caching is done. But all of these things bring down that cycle by maybe, optimistically, it could reduce the time by half. But that's still 12 or 13 hours. That's still too long. So we needed to come up with a completely different approach. So we look back at the demonstration we showed earlier of runtime theming. So what didn't seem to be as important or align as much with where we were going just seemed pretty important. What if we could change the theme at runtime? What if at runtime we could figure out where to get the theme for each site and load it? So our initial example essentially created the branding package into its own module that could be loaded at runtime. But it did not solve a lot of the other issues where MFEs need access to SCSS variables at build time. That problem would require completely refactoring the way that Paragon works into using CSS variables. And when we looked at what was going on in the Paragon world, some of these solutions were already in progress. So here are a couple of other more problems we faced. With like 50 sites, you're ending up in 200 or so subdomains. Let's Encrypt only gets you 100 subdomains in one certificate. I don't even think that's a limitation of Let's Encrypt. I think that's a limitation of SSL. So we needed to do some splitting. The Kubernetes job script file has a limit. We were exceeding that limit. We needed to find a way to break it into chunks so that we have multiple jobs for the same thing. So this is where CSS variables become really, really important. And I'm going to show you why very soon. But so CSS has been steadily gaining a lot of really, really amazing features, which seem to come from the world of SCSS, LESS, and all of these CSS preprocessors. So CSS now supports nesting, which is something that a lot of people find to be a much better way of describing how a UI is structured, because you're following roughly the same pattern in the CSS code as you are in your HTML code. It supports properties. Now, this is the most important thing for us because CSS properties are what CSS calls their variables. And this is going to be the most important feature. There are two other ones I've listed which I really like. One is scopes, where you can have, so if you apply a style to an H1 tag, it'll apply globally. With scopes, you can limit it so that it only applies to a particular scope within your HTML. And container queries, which is also a really amazing feature. Just like you can have media queries where as the size of your window changes, if it's a phone, tablet, TV, it can adapt other UI elements. Container queries allow you to do that to a particular container. Like you could have a query about the size of a div. That div could be a sidebar, and as the size of the sidebar changes, the content inside can adapt. And this has nothing to do with the size of your application itself. So you could have your application running on a desktop, but as you increase or decrease the size of the sidebar, it can adapt without using any JavaScript. But we're going to focus only on properties. So before we get into CSS variables, let's look at how SCSS variables work. So what you can see here is you have some, I've written SAS, I think it's SCSS code, where you have a variable called spacer, $spacer, which is set to a value of 1 rem by default. And then you have what is equivalent to a dictionary in Python or an object in JavaScript. It's like spacers where there are different entries in that for different sizing of spaces, like a spacer of 1, 1.5, 2, going all the way to 6. And on the right-hand side, you can see that for the margin, we are using a spacer size of 2. For another one, we're using a spacer size of 1. And when this code gets compiled, what you see is it fills in those values in the CSS file. So the problem that we face here is that although there was if you make a slightly small change, you change this the spacer from 1 rem to, let's say, 1.1 rem, or you want to work in pixels, you set it to 10 pixels. I don't know if it's a good idea, but if you do that, everything in your CSS file will change because it's being compiled at build time into a fixed value that shows up in your CSS file. So a really small change in the source code can have a huge change in the output file when it's something as foundational as a spacer. So let's see how it's done with CSS variables. So you can use SCSS variables with CSS variables. This is what Paragon does. This is an example from Paragon 23. And where there was earlier 1 rem, it now references a CSS variable. And this is the way you reference a CSS variable. You have what would appear to us like a function, and inside that is a variable name. And I'll get into the convention of the variable name a little later, not the convention, but where that comes from. And you'll notice another change, which is that instead of directly multiplying the value, you are wrapping it in a CALC function. So what this does is it applies this transformation at runtime instead of at build time. And we'll see in a moment what that means. So the code on the right has not changed much. Instead of using an SCSS variable for the font size, we are now using a CSS variable, which again means it will resolve at runtime instead of build time. So when you look at the final end result of this code, you'll notice that there's a lot of difference here. And what it's doing is it's using the base value of the spacing to calculate at runtime what are the relevant values to use here. What that means is that if we plug in another style sheet along with this one, where the spacer value is set to 1 rem, and then we replace that style sheet with one that sets it to 2 rem, suddenly everything in the UI will get spaced higher. And that's a change of a few bytes rather than a change of the entire spreadsheet. So that is the amazing thing with CSS variables and the calc function. So one thing crucially that CSS variables do not support is, as far as I know right now, I don't think there's any way to modify colors. So you cannot create lighter and darker shades of colors. You still need some level, some build step. And we'll get to that build step when we get to design tokens. So Paragon 23 is the release that brings all of these things together, and it's a truly magical release. It's, I think, one of the most significant releases of Paragon since maybe the beginning. So here's like an example, and this is not a very realistic example, but here's an example of what a style sheet could look like that could change these 5 variables. So it's changing the base color for links, it's changing the footer background color, and you can have your own properties like this if you have your own code that's using CSS styles. And the reason why I say it's not realistic is because this is just changing the base brand color. You still need to change the variants. So how does what does Paragon 23 bring? So Paragon 23 changes not just the way that it changes the way that Paragon is structured. It changes the way that Paragon is built, the way it's deployed, the way it's used. That's, I think, almost all the aspects that a package can have. So for instance, Paragon, the theme that it builds is now split into 2 parts. This was, I think, roughly the case before as well, but now it's like a lot more formal. You have a core style sheet and a theme style sheet. And the core style sheet has all the main structure of Paragon. It brings most of the functional CSS code in. And then the theme CSS just has CSS variables that plug in all the places where CSS variables are required. There are CSS variables in the core theme as well, but what the theme file does is it plugs in all the theming related variables, and by changing anything in this theme, you can have a big impact on the site. And the way you use it now is by specifying something at build time and very soon at runtime called Paragon theme URLs. So by providing this configuration, you can replace any theme, any aspect of the theme at build time. But if you deploy to these URLs at any point of time, it will update the theme instantly. So you'll notice that these have references to a CDN, because now Paragon can load the style sheet from a CDN. And the reason it's important is that if multiple MFEs are using the same version of Paragon, they're going to be referencing the same URL, which means it's going to be cached. Earlier, if you just started from the base platform and you went from the authentication MFE to the learner dashboard to the learner MFE, you've already loaded Paragon thrice. Not all of it, because some of it will be deduplicated. And crucially, this is only talking about the theme. It's not talking about the components. Those are still going to be not that duplicated. But if you've attended the composable front-end talk, that's also probably going to improve with that solution in place. So you'll notice that there is an entry for variants where you have a single variant right now, the light theme. This is the default theme. You can imagine having a dark theme, a Christmas theme, a Diwali theme, a New Year's theme, whatever. If you want to have themes that change according to what's going on in the world, you can have that with much greater ease. You don't need to rebuild each MFE. You just need to update these URLs, and what you get is a completely different look for your site. So what is the build step now? And that build step now comes from something called design tokens. So the way that I like to think of design tokens is that each design token is an individual design decision about the smallest aspect of a design. I could be wrong, I'm not a designer, but this is how it helps me understand design tokens. So here's an example. We have what makes up a button? What makes up the design of a button? You have the color of the text, you have the color of the background, you have the font, you have the style of the border, the color of the border, maybe the thickness of the border. You have maybe there's a shadow element. You can have variants of the button. You can have a primary button, you can have a secondary button, you can have a large button, you can have a small button. So each aspect of those is like a small design decision that all come together. So if you have a variable for each one of those design decisions or design tokens, you can completely modify the UI through just changing some of these variables. So here are a few variables that are related to a button. All the design tokens start with like the namespace, what kind of aspect of design is it changing. So the first one is spacing, and then you have a dot btn standing for button. Padding, it's dealing with padding. X is for the horizontal, like the horizontal padding, and LG stands for large, so it's dealing with the padding that needs to be applied on a horizontal level in a large button. Then you have the button hover text primary. So what is the text color of a primary button when you're hovering over it? As you can see, like this is pretty granular to what you can do. Then you come to the border radius. Again, I think there's an idea you can get from these examples. There are probably hundreds of design tokens just for the button itself. So let's look at that, how that ends up in Paragon. So this is the humongous effort that's gone into Paragon, which is every design variable has been turned into a design token, which you can eventually modify, and that can lead to, with the same style sheet, a completely different design. The ones that just scroll past are part of the core style sheet, and the ones that will scroll past now have to do with the theme. So what does the content of these files look like? I'm going to take a small snippet. This is not a full example, but it's a JSON file, and you can see that there's a nested structure here. You have a color, button, hover, text, primary. This is familiar from the last example. And one thing you'll notice is that there's a dollar value here, dollar value attribute. That is the value that is going to be applied to this particular design token and be pulled into the UI. And this value is referencing another value. It's referencing the background color of a primary button when it's hovered. And this might feel a bit weird, because why is the color of the text the same as the color of the background? That's because there's another entry here called modify. And what modify is doing is it's applying a modify operation to the source value. And what this particular modification is doing is it's finding the best color that goes with that background color. It could be a light shade or dark shade, depending on the color of the background. And the source is the original SCSS variable, so that when you need to migrate your own code, it can do that automatically. So this is how you might use it in your own code. You can specify this in your own design token file. It'll build out that value and plug that in to your style sheet and make that change. And we also added support for TOML. TOML is another format, and it kind of, for me, I feel it maps much closer to what the end result is. And it's both are representing the exact same thing. So it's worth looking into TOML for this as well. So coming back to our old example, I kind of promised that with this theming, we managed to make theming exponentially faster. So what were the end results of that work? So we were heading towards a situation where we had about 50 sites taking around 20 to 25 hours. Now we need to deploy only a single instance, a single version of each MFE. And because it's at different URLs, it's going to pick up a different theme, because we can load this with, once we move to front-end platform version 8.3, it can load at runtime. So in the next release, that should happen. So that once we, so what we have done with in our use case is kind of pull in those changes a bit early and have it work at runtime. So the build process for 50 sites, 50 themes for us takes under a minute, compared to where we were looking at 24, 25 hours. But this is, again, only about the theme. If you only need to make a theme change, within a few minutes, it'll build out the CSS tokens and the CSS, build the design tokens into CSS. And within maybe another minute, that gets uploaded to your CDN. And maybe in one more minute, just to let the caching and all that work. These are really small files. The design tokens produce really small files, because the only variables it changes, the only variables it puts into the final CSS are the variables that have changed. So you end up with just like less than 1 KB of a theme, which can make a huge impact. That was the case for us. And that took under a minute for 50 of those. And deploying maybe another one. So within minutes, we can now see a theme change, apply onto our sites. So I want to give huge thanks to a lot of people from Axim and edX, specifically Diana and David and Adam. There are a lot of other people that whose work I came across, but I think their work is something I came across again and again. So a huge kudos to them. They really made something that at the beginning seemed like it would be a lot of effort. It still was a lot of effort, especially using future versions of Paragon. We've been using the alpha version for over a year now. That was difficult, but that was a challenge we took for ourselves. And the major work was already done for us. And yeah, that's all from me. And if you have any questions, you can ask them now.
Get this box ready so when people have questions, we can get them on the recording.
I was just wondering your thoughts on other aspects of theming, if we could make them happen at runtime, like changing the header or plugins and stuff like that.
I think there was some
colors.
discussion about that in the composable frontends workshop day before yesterday. And essentially, like, this is something that's been postponed to think about in the future because I think they added module federation code which would allow that and then removed it because that's a problem that doesn't need to be solved now. I mean, I don't know that well, but from that attending.
Yeah, the way I've been saying it is we need to get to a point where we actually have modules before we can think about federating them. So, yeah.
Yeah, so I don't think right now, I don't think it can happen at runtime, but you can have multiple slots and change which slot gets loaded just by having that in the config API, and that's to an extent can be done at runtime.
Have you thought or considered about doing something around the lines of Tailwind, like utility classes or something like that, that would allow us to switch some things, almost not on the fly, but almost on the fly if we need to do something like that to Paragon?
I mean, it's already happening on the fly now because the theme file is just so small. Even if even at the maximum level, it would be 10 kilobytes, and that would change almost the entirety of Paragon. So it already does that. I think, I don't know because I'm not that involved in the core aspect of Paragon, but I would say moving Paragon away from Bootstrap to something like Tailwind would in any case require like a lot of code on the Paragon side to just reintroduce a lot of the Bootstrap classes just so that every MFE doesn't need to be changed. So you're going to end up with the same problem again. You'll reinvent Bootstrap on top of Tailwind. So I don't know if that would ever happen. But yeah, I think just using like there's a tendency to have a lot more SCSS code in MFEs. If you stick to just using the existing classes, a lot of those problems kind of die down a lot.
About the variants,
Yeah.
how are we generating them now? Are we still using?
So design tokens has a mechanism to do that. Instead of using SCSS, there's design tokens will generate those variants for you. So you can hand code the CSS theme if you want. Design tokens just make it easier. You can have maybe like a server-side service that is generating the style sheet. It could be generated automatically, like you could have some kind of backend code that generates these variables from a UI that you have. And so you can change a theme and it can instantly show up. That is possible, but I think design tokens just like formalize this in a pretty neat way, I feel, as a non-designer, that I don't think hand coding, like even if you want, you can plug it into design tokens, build that. It's pretty quick. It's really, really quick.
And under the hood, design tokens are using a style dictionary to take the tokens and turn them into CSS. And they can also be transformed into other styles. So if you want to look into that technology, style dictionary is what you should be looking into.
Yeah, so that's a really good point that this none of the design token thing is specific to the web. You can imagine generating like an Android style or an iOS application style or a desktop style from the same thing in whatever native format you want. These are just core decisions that can be applied in many different ways. So you can pull in the decisions you want to make your Android app, and it can be themed the way that your web app is. But that code is not there right now. It could be in the future.
All right. Well, if there are no more questions, thanks everybody.